All right. So again, this one, there were a few questions. The first two, no, the last two again are really similar. So I will just do one of those. I'll do the harder one. This one's actually the harder one, the second one. Okay. These are both dilution equations. So this is where you use the M1V1 equals M2V2 equation. And then the first one is just determining the moles, or actually grams, of a solution that you want to make 50 milliliters of it, but you want it to be a particular concentration. So like, let's say you have this flask and you want to make 50 mils, but you want the concentration to be 0.08 molar. Well, that's moles per liter. We don't have a liter, right? So it's not going to be 0.08 moles. It's going to be something less than that. Also, when you make a solution, it needs to be in terms of grams, because you can't weigh out moles. You only weigh out grams. Okay? So we'll do the first one first. We're going to go, and I'll do this, the unit route, the kind of plan for our calculation. We're going to go from volume. We'll go to liters actually first. And then once we get liters, we're going to go to moles. And then we'll go from there to grams. So this one's just a metric conversion. This is using the molarity. And this one is using the molar mass. Okay, so 50 milliliters, divide that by 1,000 to get it in terms of liters. And then for the molarity, separate that into moles per 1 liter. Okay, so the number of moles that we need for that 50 milliliter volume is 0.004 moles. Now, we want to know the number of grams, though. So we're going to need the molar mass for K2CrO4, which I'll just give you guys that. That is 194.1896 grams. So we're going to take that mole, and we're going to say in 1 mole, there is that value of grams. And that should tell us our answer. So 0.004 times 194.1896, or 0.777 actually grams. Okay, so you would have to add that amount of grams into a flask, fill it up to a total volume of 50 milliliters, and then you would have 50 milliliters of a 0.08 molar solution. This is actually stuff that you guys did in Chem 1. These are all review problems. So if you need to go back to that chapter, I think it's 6, I want to say, you can look in there as well. Okay, so M1, V1 problems, M2, V2. This is going to be, I guess this one is a little bit more complicated than a straightforward one. I can leave that for you guys to do, though. This first one, the reason why people would struggle with this is because you're actually losing volume. They're saying that you put a container out. This is your original molarity and your original volume. And then you let it sit on the, the counter, and you lose 45 milliliters. Okay, so what does that mean your new volume is? Well, your new volume is 252 minus 45, or 207 milliliters. It evaporated, and now it's 207 milliliters. And they want to know, what's the new molarity? Okay, so I'm just going to plug into this equation. M1, 0.459. V1, 252. M2 is what we're looking for. V2 is 207. Okay, so all I have to do is solve that. 0.459 times 252 divided by 207. So that new molarity is 0.559 molar. So it's more concentrated. That makes sense because you had some evaporation and now you've got the same amount of solvent or solute with less solvent. Now for the next one, it's going to be the same equation. It's just that you're first going to have to convert this grams of potassium iodide to moles of potassium iodide. And then you're going to have to use that volume here to convert it to molarity. So then you'll have a molarity and you'll solve for that new volume. Okay, so this would be your M1, V1, this will be your M2, and then you'll be solving for V2.